So we were looking at the aliasing effects, right? So if you can see these waveforms, right? Recall, we had the original signals, and then we had this waveforms, okay, which is in blue and green, right? So the one in black is actually the original signals, right? And the one in blue and green are the samples, right? So we learned that aliasing is a very important step, right? Where we tried that at different frequencies. So the best frequency to do it is greater than or equal to 2 times the maximum frequency, which is FM, right? So all these are called aliases, right? Which is actually replicating the original signal, right? So to sample a frequency at least twice higher than the highest frequency present in the signal spectrum. So that was called aliasing, right? So you can see here, right? So this waveform, the one in blue, is actually very close to each other, right? Compared to the black one. So which means we can understand the frequency is higher, right? So approximately you can find it to be a twice with the higher frequency, right? Okay. The next that we have here is a 30 frame PCM system. I don't know how many of you are aware of this. So what I will do is probably I will keep this point pending. I will show, yeah, I have it here, right? So in this diagram, right, so we see that there are 32 time slots, okay? So this is pulse coded model excuse me, this is pulse coded modulation system, right? So it's also called 30 channel PCM system, right? So here what I'm trying to ask here is, what is in time slot 0, what is in time slot 16, 1 to 15 is signifying what, 17 to 31 is signifying what, okay? What is time slot 0 when it's an even frame, and time slot 0 when it is odd frame. So basically, we are referring to these time slots alone, okay? So channel 1 to 15, channel 16 to 30, and these are the time slots, right? So this 0 time slot is actually used for synchronization, and time slot 16 is actually used for signaling, right? So there are various information, just like if we break up data, right? So it's actually huge data is broken up into packets of information, right? So in bits and pieces, they move from one point to another, right? So in this packets, right, so we see that it's actually a binary combination, right? So information is all in the form of binary, because these days we are very much dependent on digital mode of communication, right? Okay. So you can see here that you can see that there are 32 time slots, right? So we will see one by one as to what exactly it is referring to. Okay, so just have a look at this in 30, okay, in PCM 30, what is happening. Okay, just have a look. So you can see here that there are different information. So exactly at PCM 30, okay, time slot 0, very interesting, right? So you just try to match up here, try time slot 0, right? Time slot 16, time slots 1 to 15. Okay, just go through it. So time slot 0 is actually dedicated for synchronization, as I told you, right? So is it important to have synchronization when we send data? Students, I think we have discussed this in our previous sessions, right? So is it necessary to have synchronization? And why is it so? Yeah, can I have a response? Why is synchronization necessary when sending information? Is it really so important? If so, why? Okay, synchronization, I have an answer here. Synchronization is needed because the signal to be sent remains intact with carrier signal in a particular time frame. Good. So we are looking at time-based information transfer, right? So I think you would have studied even in your labs, right? HDL labs, where we have synchronous reset, asynchronous reset. So exactly what is happening. So this is referencing its operation with respect to time. So if we do not have it referenced with time, then it becomes difficult for us to pass information. So let's say that, I have passed about, 10 packets. So I need a confirmation, so for that confirmation, what I'm going to do, I'm going to use an acknowledgement. So I will know that, yeah, after this 10th packet, I have to send the 11th packet, right? So there is a kind of timed, delivery of information, okay? And this happens only when, we reference our information with respect to clock, okay? Right. So clock, plays a very important role, and without clock, it becomes almost impossible for us to communicate effectively. Okay. So packets of data are triggered at a particular time, right? And once the time, has arrived, so immediately the packet is delivered. So now let us see, one by one as to what these time slots are actually referring to. Okay. Fine. In PCM30 system, the frame comprises of 30 time slots used for traffic and 2 code words that are used for synchronization and signaling. Now, synchronization, I have told you, right? It's important because, it is intact with time. So as the clock, keeps going high, it can be probably, the rising edge or probably the falling edge, right? So based on that, we will be able to decide, what kind of information, and when the information is actually triggered. Is it triggered on the rising edge of the clock, which means from a lower value to a higher value, or is it from the higher value to a lower value? So you can just imagine, you know, a clock signal, right? Okay, so we will just assume this pulse, and if we are concentrating on this part, okay, where it's moving from a higher value, from a lower value to a higher value, then it's called a rising edge. So if in case, it's the reverse way around, okay, if I'm concentrating on the falling edge of the clock, which means from a higher value to a lower value, then I would call it as a falling edge of the clock or negative edge of the clock. Okay, fine. I hope this concept is very much clear with all of you. Okay. So synchronization and signaling. Fine. A PCM30 system carries 32 time slots. Okay, each 64 kbps. So now here, each time slot that you can see here, okay, which is actually 0 to 31, so that makes 32, and 2 are exclusively kept for signaling and synchronization. 0 and 16 just in the start and middle. Okay, it is kept for different purposes. So this gives a total bitrate of 2048. So if you can multiply all of these, right, or probably if you can just see that it is 64 kilobits, right, and you try to multiply it with 32. Can someone do a quick math here? 64 into 32. Yeah, so we should be getting exactly about 2048. Just you can do your math, we're getting 2048. So each is pertaining to 64 kbps, right? And when I multiply it with 32, I'm getting the number 2048, okay, which means 2 kb. Fine. PCM30 frame consists of 32 time slots. We have seen that. Now time slot 0 is dedicated for synchronization and management of information. So synchronization, as I told you, is important because we can manage information. How can we manage information? Because we can see that with the help of this synchronization, we are able to check if data is moving a line, or if one packet after the other is being delivered. And with respect to time, one more catch is that with timed circuits, okay, when I say synchronized circuits, you need an extra circuit which takes care of the time exclusively, right, to keep track of time. So that is one overhead, I could say, with timed circuits. And with untimed circuits, with asynchronous types of circuits, right, of course the data overload is not going to be there, because there is no reference to time, but then it's less reliable. So I would say even though the system is a bit loaded with data, it's better to go with the synchronized mode of transfer, okay, so that we are intact with time. So it's like a timestamp, right? So it's like whenever you send a message, there's a timestamp, right? So here also, whenever there are packets sent, okay, it is being referenced to time. So based on the clock signal, it is transferred. Okay, so time slot 16 is assigned for signaling information. Okay, so in short, sometimes we also call it as CAS. CAS. So this is the time slot 16 that I'm talking to you about, right? So signaling, telling that yes, I have received, and you can send me the next one. So time slots 1 to 15 and 17 to 32 are voice or user information channels. Okay, so these are all voice channels. Okay, the one that you can see here from 1 to 15 and 16 to 17 to 30. So what they have done here is they've taken 1 to 15 and 17. Fine, that's okay. In even numbered frames, time slot 0 carries frame alignment signal. Okay, so this is also called FAS, frame alignment. So this is going to check if it is aligned, if it is in proper order. Okay, so we have something called cyclic redundancy bit, okay, CRC check. So you'll be learning exclusively on this concept in your communication subjects, right, be it analog or digital communication. CRC, okay, cyclic redundancy check, is a very important check which keeps track of frame alignments, which keeps track of data alignment, okay, which keeps track of any extra information that is being transferred or any duplications that are going to happen. So all these are checked. Fine. For ensuring the frame alignment recovery, in case someone is sending, okay, let us say, some information like 0011 on user information channel. Okay, so this is going to ensure that the recovery is proper. Okay, so you can probably assume it like decoder and encoder. So if I send some information and if I receive some other information, do you think the communication was successful? Was it successful to have such sort of communication? I don't think so, right? So whatever is in the source, right, that should be transmitted to the destination. There can be a slight delay, probably few nanoseconds or few microseconds, but then it's very important to have information passed from one end to the other without loss or very minimal loss, right? Okay, so yeah. So time slot 0 in odd frames carries alarm information. So this alarm information is, say there was a wrong or extra a packet, or probably, that packet was not aligned properly after the, packet that was just sent. So in that case, this will raise a request. Okay, once it raises the request, then, it will be able to check, okay, fine, I have not received proper information, so I am going to stop at this time point. Okay, and I'm going to retransmit my information. So you can see here that there's going to be a very reliable transmission that's going to happen between the transmitter and receiver, right? So information is kept intact. Okay, so okay. So the second bit is set to constant value of 1. So basically, you should understand that when we are passing information from one end to the other, there are a lot of algorithms, there are a lot of optimizations, there are a lot of calculations that happens actually, right? So you can see that just for passing information from one end to the other, we have divided the time slots, and again in that time slots exclusively we are assigning certain tasks for each bits at a different time slot. So all these are done to have a reliable communication, right? So only when we have a reliable communication, right, so that's when we will be able to understand the importance of you know uh, having a lossless communication, right? So now, with respect to PSTN, which is public switched telephone network, right? So these are the networks which were there previously in the wired connections, the landlines, probably you could say, uh, uh, how these connections, come from, the main switching center. Okay. So with respect to this PST, I'll explain how it's an example of circuit switched network. Okay, so it is basically switching happens because of a specialized circuit. And what are its applications? Applications of PST. Very simple question, right? The public switched telephone network is a worldwide collection of interconnected public telephone networks that was designed primarily for only voice traffic. So previously, when we had this landlines exclusively at our houses, we had just one phone, and everyone used to use it, right? So there was no personalized use of any apps or probably the internet connectivity, right? So these days, that's not the case, right? So we have personalized internet connections, personalized speeds, personalized packages, personalized validities, right? So now things have changed a lot, and the speed at which the data is being transferred also has been evolved to a much greater extent, right? So things are to be appreciated. That's all because of this, research and development that's happening, exclusively in the field of communications. Right. So it was, this PSTN was basically built for carrying only voice traffic, but not data. Okay. So data was not at all in the mind. So hence, previously we used to have a very minimal connection, wherein BSNL used to provide this landline based internet connections, right, where we had to connect, and it used to give all sorts of sound. I don't know how many of you are aware of that, right? So so if it's connected to the internet, then the voice calls wouldn't work. So whenever another person calls to that number, it always gives you a busy tone, right? So that's how it used to be. So it was not multitasking, I could say. um, Either it can be used only for data, or it could be used only for voice. So that was the level of technologies those days. Okay, so the PSTN is a circuit switched network. Okay, so as I mentioned, it has a special circuit, or I can say it has a dedicated circuit. Okay, so we can also probably sometimes refer to it as channel. Okay, so this was establishing the duration of a transmission, such as a telephone call, and this contrasts with packet switching networks. Packet switching networks are basically only dependent on sending information in the form of packets. Okay, so with packet switching networks, in which messages are divided into small segments called packets. So a long message is broken into small pieces, and those pieces are called packets. Okay, it's just like a photon, right? An energy, a packet of energy. Right? Okay, the internet is based on packet switching protocol, so we also call it as TCP/IP. Does someone know the full form of this? TCP/IP. Anybody knows the full form of it?
Sir, is it internet protocol?
Good. IP is good. How about TCP? Transmission control protocol. Okay, so that's how information is passed, and how you can actually open up your computer, and when you go to the network settings, you'll be able to see this IPv4, IPv6. Have you ever imagined what is this IPv4, IPv6?
Or are there different versions?
Of course, there are different versions, but then, like, have you thought about it? Like, what is V4 talking about? What is V6 version 6 talking about? So,
sir, is it the numbers like 192.163?
that is the correct sign. That is the IP address. Now it is, let us assume like this. So we have a population of, say, 1 billion people, right? So if I'm using this telephone numbers, right, having say about 5 digits. Okay, say if my telephone number is 12345. Okay, so can I cover all this 1 billion people if suppose all of them opt for connections? Can I provide them with mobile numbers? Not possible, right? So I would exhaust all the numbers. So hence what we did, we have a 10-digit mobile number, right? So in this way, I was able to cover up most of the population. And the other clever thing that was being done is, if suppose a number is allocated, say 1 2 3 4 5 6 7 8 9 and 0. So if this 10 digits is allocated to a person, and if that number isn't used for a long time, it was recycled, right? So in that way we were able to save different numbers. But then when we talk about this internet connections, right, there were billions, I could say, millions and billions of websites that came up, and which needed a lot of IP address. So you might type google.com, but then there's something called DNS, Okay, so DNS is domain naming service. So when you actually go into your command prompt, okay, and try to do a ping. Okay, let me probably try showing you that right now. That is going to be a little interesting. So you go here. I think you're able to see, right?
Yes, sir.
Okay. So here, you can just type CMD. Okay. And this command prompt window comes, and you can just say ping space google.com. So you can see that a number will come up. Press enter. Okay. You can see that a number is coming up. So this number is actually referring to the website. It's the address of the website. Okay, 172.217.160.206. Right. So here I'm seeing that I've got 4 replies. Right, packets sent is 4, and I have received 4, and loss is 0, which means there is no loss at all. So it's a 0% loss. And here you can also see with respect to the packets, some more information is given, right? For example, how much time it took, okay, in milliseconds. The minimum time it took was about it. Minimum and maximum are of course shown the same, 29 milliseconds, and average is going to be 20. So how much time it took for the request, right? So this number of seconds that you can see here, let's say for example you had got here say 30, and here 29. So this is going to add them and divide by 2 and get the average here, right? So this is how the information is actually passed from one end to the other. So you can see it is in the form of packets. So when I was telling you about this IP v4 and v6, why this topic came up was because of these addresses that you see here, right? The IP addresses. So these addresses were all used up in version 4. So what they did, they increased an octet. So what is octet? This 172 dot, okay, or let us say just 172 is called 1 octet. So they increased the number of octets in version 6. So with the help of that, it's like increasing the numbers, and with the help of that, we were able to assign different specific IP addresses for different websites, right? So that's the whole idea about version 4 and version 6. So I hope that point was clear for all TCP/IP. Okay, you can actually when you go to your computer, right? Let me show you. If you can just type nc pa.cpl, right? So you'll be able to see the connections. Let's just wait for a minute. Yeah, and here when you do a right click, properties. Okay, so this is your LAN properties, local area network properties, and see here you'll be able to see this IPv4 and IPv6, right? So I hope have you all seen this in your computers anytime? Yes, no? Have you all seen this?
No, sir.
Net protocol version 4, version 6. Yeah, it's a very interesting thing, so probably you can try to see as to what this is talking to us about, right? So very, very interesting concepts. Probably you can take up networking in your upcoming electives, where you'll be learning actually in detail about all this, right? Okay. So yeah, so I think we will stop here. Okay, and we will continue in our next class. We will see about the applications where this PSTN will actually holds good.